Hey guys, here's a video on adding and subtracting radicals. So the requirement to add and subtract is that you have the same radicand and same index. Remember, the radicand is what's under the radical and the index is the little number on the outside. So whether it was a cube root, fourth root, square roots obviously don't have a number out there, but it's that little number out on the outside that tells us what we're using. So when we have the same radicand and same index, we're talking about like radicals. And you can only combine through addition and subtraction radicals that are like. You can't combine ones that have different radicands or different indices. And I know it seems ridiculous and seems difficult, but in reality, it's not that bad. So let's talk about some like radicals. Like square root of 7 and square root of 7 and 2 radical 7. So notice that they all have the same index. It's 2 on all of them, and 7 is the same radicand. It doesn't matter what the number is on the outside. Another example could be like radical 8, 2 radical 2, and 4 radical 2. Now you're probably wondering, well, that 8's not alike, but if you simplify it down, you would get radical 4 radical 2, which is 2 radical 2, and if you simplify it, it will come out to be like. So just remember that sometimes they're not going to be all the way simplified, and you have to try and simplify everything to get there. Unlike radicals would be like radical 13 and radical 9. Those guys will never get along. You simplify radical 9 as 3, there's no way to simplify the other radical. They're not alike. Or something like the cube root of 18 minus the square root of 18. They have different indices. Right? No matter how you simplify those, it'll never work out because their index is different. Let's try a few problems. So here's ones where the index and the radicand are not changing. You have 5 radical 2 plus 3 radical 2. This is as easy as it gets. You keep your radicand, you keep your index, and you just add the numbers on the outside. 8 radical 2. It's addition, right? As long as everything's lined up, you're set to go. Number 2 would be, I want you to try number 2. Number 3, 2m cube root m, 5m cube root m, minus m cube root m. So we're talking about everything cube root m. So that's good. And you have 2 plus 5 is 7, minus 1 is 6. M cube root m. So far, so good. I think you guys can do the rest of these. Except let's look at number 4 right now. So you have cube root 2x, cube root 2x, and cube root 2. Well, you might think you're not going to do anything, but what you can do is combine the ones that do have the same radicand. This one's a loner. It's going to have to stand on its own because the radicand is not the same as the other two. So you have 9 cube root 2x plus 7 cube root 2. Right? You can combine what's the same, but what isn't, you leave alone. Just like with numbers earlier in the year with our equations, when you have numbers and variables, you have to combine what's like and leave alone what's unlike. So let's look at these. This is kind of what I was referencing earlier, where you could start with unlike radicands, but get to like radicands. So these appear to be unlike. You have 8 radical 2, negative 2 radical 8, and plus 2 radical 18. So let's simplify all our radicals down to their simplest form. 2 cannot be simplified any further. This radical 8 can be radical 4 times radical 2. Radical 18 can be radical 9 times radical 2. Again, if there's a bigger perfect square that goes into it, you need to take that out to make it as simple as possible. 8 radical 2 minus 2 times 2 radical 2, right, since square root of 4 is 2, plus 2 times 3, square root of 9 radical 2. So you have 8 radical 2 minus 4 radical 2 plus 6 radical 2. And in the end, that becomes 410 radical 2. So while that problem, initially looks like something you cannot do, once you simplify all these to their simplest form, it's a very easy addition-subtraction problem. And I believe you guys can all do number 7 and 8. Although they appear to be bigger, if you simplify them down, you'll be just fine. All right, that's it.